Almost there.
Do you hear me, Michael?
I hear you.
Why the video is not coming up? Failed to start camera. Having issues. Try again. It's not Zoom who is taken over. Let's see in the settings. Device.
Yes, looks like
All
we
right.
got it all figured out.
I don't know why, but I think my camera needed 5 more minutes.
Yes. Always takes that. Well, good
Yeah.
afternoon, Jan.
Good morning, Michael.
Yeah, I don't know if my room looks any cleaner. I did tidy things up a little bit in order to take my Kafka test on Friday, so
How
I
was it?
passed. I am certified.
Congratulations.
Yay. Yep. Yeah, it is a very difficult test. So I just barely passed.
That's enough.
Yeah, that's enough. Any more would have been waste. Just
It's
meant
a
that I
binary
spent too
thing.
much time. Yeah.
Either you fail, either you pass.
Yeah.
Um, no, congratulations. That's really good news.
Yes, thank you very much. Yeah. So yeah, now I'm thinking about the different ways that Janaga and Kafka can interoperate. And yeah, I think there's a really good a really good pairing there. Is that Janaga is really great at the kind of the human level, the human sized data, and moving it from place to place. Whereas Kafka is all about taking that, turning it into a stream, and then processing along the way. So you end up with the same information, but in different forms in different places.
Okay.
So yeah, I'm
So it
hoping
might be
to.
complementary.
Yes, yeah, I think so.
Okay.
Yeah. So I'm hoping to have a good demonstration of that complementary nature in the code launch application. So yeah, with the code launch app, each attendee puts in their votes for for who they want to win the competition, and then all those votes are tabulated, and that tabulation is effectively a stream processing operation. All these votes go into a topic that is interpreted as a stream, and then they're pivoted. So now instead of looking at the individual history, you're grouping them by the attendee and saying I'm only interested in the last one. So then now that kind of pivots it to kind of a table of each attendee's last votes. And so their last votes are an array of allocations. So I'm going to give so many points to this contestant or to that contestant. So then they need to be, all those arrays, all those vectors need to be summed up and then pivoted again. So now you just get a very small table on the other side. For each contestant, what was the total? And that is a perfect stream operation for Kafka.
Okay. But so it becomes more complex because you need Kafka and you need Jinaga.
Yeah, that's true. That's true. Yeah, right now I have that logic just happening in memory inside of a Janaga client, and it's enough for testing and for for continuing to build out the application. But at scale, that's not going to be a good solution. So it would be much better to have a streaming platform to process that data in motion.
And you will be finishing all that before the event?
Oh yeah, no problem.
Okay. Yeah,
Yeah,
you are incredible.
yeah,
You
me
are
and Claude.
incredible.
Yeah, me and Claude are good buds. We can get that done.
Yeah. Let's see. I got a little bit farther.
Excellent.
but I have a lot of questions again, like usual.
Mm-hmm.
Wait, how are we gonna do that? Let me share first. Where is it? This one. Yeah, so there we are in Visual Code, VS Code.
Yes.
So that's on a virtual machine. But I think it's time to bring VS Code to my main machine
Uh-huh.
because it's very annoying switching all the time. Right, let me just back up commit. I can amend it later, but at least. Is it readable this way? Or
Yes, it is. Yes.
So I've been working mainly on the model. I did a few commits earlier this week, but that was just small things. For example, to the dispatcher and the administrator, I also added a restore possibility. Because in fact, a dispatcher is a kind of role of a user. And I can imagine a user that is first a worker, then becomes a dispatcher, goes back to being a worker. So you have to delete the dispatcher
Yes.
role. You might have to restore it.
Yes.
Let's
Good
start
thinking.
from the beginning here. Okay, so the supplier is still in front. Nothing has changed there. We don't delete the supplier because then it's finished. Then I put the username first. So username, nothing special here. Then we have an administrator. The administrator can be revoked and restored as often as needed.
Yes.
Yeah. So we just have here is revoked, revoke, restore. That's the diagram. The dispatcher, exactly the same, is revoked. And his name's here with a revoke and a restore possibility. And so there is a revoked date over here.
Right, yes.
So we can revoke and restore multiple times. Then we have the worker. That was already done last week, I think. Same revoke, restore. The clients. I don't think that I changed anything here. No. And then we get to the yard. So the yard was a successor of a task, of a client initially.
Yes, yes.
And so let's move this rubbish out of the way. What I did here, I put the yard directly under supplier.
Yes.
It has a yard delete and plus restore and mutable properties.
Nice.
So a yard is now an independent entity. It can be linked to a client by means of a membership pattern. And modeling it in this way has the following advantages. It allows the link yard client to change. For example, a yard can be sold.
Yeah. Yeah.
A yard can be linked to multiple clients simultaneously because you could have an order from somebody else to to come and work on a particular piece of land. And it allows an easy follow-up of the history of a yard over the full lifetime, independent of the linked client.
Yes.
The yard can be deleted and restored. So I think here nothing special. So we have the names, we have the addresses, is deleted, delete, restore, name, address. I think there is nothing special here. That does have influence on the CRM client or yard relation, but there I didn't modify anything yet. Because I think in the CRM database, you will always have the relation client yard.
Yeah.
So we will come back to that later.
Okay. Yeah. That would be an interesting change.
Then here, a tool. Okay, we discussed last week about that, but I still was thinking some things are not working. So a tool belongs to a supplier. It can be deleted, restored, and a tool has multiple properties. For example, a name. Tools can be added by workers, but until approved by a dispatcher, they should only be visible to the worker that created the tool. In this case, we need to know the creator of the tool, so the worker that created that tool. And we spoke about another option that was to show unapproved tools to everybody, but in a warning color. This might be useful, for example, in the case where multiple workers are at the same yard and all need access to the new tool.
Right.
Yeah, so that avoids that they all
Yeah.
create that new tool and that we have doubles. So in this case, no need to know the creator of the tool, although it might still be useful information for the dispatcher so that he can educate a worker who adds new tools without verifying their existence. Because it's too easy. You don't check and you just add new ones.
Yeah.
But if we don't store the creator, then the dispatcher has no way to go.
Yeah, makes sense.
Then the fact that a tool is created by a dispatcher does not automatically imply that it is improved, as a dispatcher might change role later. So
that's a good point.
that's where I saw a problem now. So you say if it is created by a worker and it's not approved, then and there is no approved fact, then it's unapproved. If it is created by somebody else or just by null, then it is approved. But imagine that it's created by a dispatcher and the dispatcher turns into a worker later on, and all the tools that he created become unapproved.
Oh, yeah. That is a really good point. Yeah, didn't think about that one.
So I think we still need an approved fact for every single tool.
Yep. Yeah. Yeah, and the shape of the query, the shape of that specification should have made that obvious as that you're looking at who the user is, and then you're coming back down. You're going to a successor to figure out what their role is. So yeah, if there exists a and so that means that you change that successor, like you revoke their distributor access, and then everything changes. Yeah, that is a good catch.
Then further on, after creation, only dispatchers should be allowed to delete tools or change their mutable properties.
Yeah.
So a worker can just create it, but he cannot change it anymore.
Yeah, that's going to be a challenging rule. Yeah, we'll have to get back to that one and see how to do that. Yeah, because the rules are really around, the authorization rules are around who can
Mhm.
create facts.
Yeah.
So the very first tool name fact isn't in any way distinct from uh, successive tool name facts. Hmm.
Anyway,
Yeah. Yeah. Yeah.
we can
Well.
solve that just by a user interface thing.
Yeah.
If
Yeah.
the logged in
Perhaps.
user is a worker,
Mm-hmm.
um, is that true? Or are we in the same logic
Yeah.
of a dispatcher becoming a worker?
Yeah.
We will
In
solve that.
general, yeah. I don't like to solve uh, solve security problems with the UI because
Mm,
I think of the UI as just a convenience for accessing the model. It's really the model that the user is interacting with. So
mm,
all the rules by which you want the user to play
mm.
should be expressed as authorization and distribution rules. Um,
I know.
yeah.
It's bad practice to do
Yeah.
so, but I often do it, but don't tell anybody.
Yeah.
Uh, we will think about that
Okay.
a little bit further.
Yeah.
But so we have tool, we have the names, we have is deleted, so that has not changed. Tool delete, tool restore tool name, tool approved. So very little changes here.
Mm-hmm.
So it becomes like this. The only additional link is this tool has a
Right.
user,
Yeah.
a creator.
Yeah. Makes
Type of
sense.
work, for the moment I didn't change anything here. Type of leave also not. But then it becomes interesting. Then we get to the tasks. There will
Okay.
be a lot of tasks in the system.
Yeah.
So in the initial model last time, we said we need to use the pattern, the period pattern,
Yes.
which we didn't have in this model yet.
Oh, yeah, that's true.
So I added this one. So a task period,
Yeah, good.
which has a supplier as predecessor. And so I have a year and a month as two integers. Is that the best way to do it?
Yes. Yeah, that
Okay.
makes it distinct. Whereas if you'd
And
used
then the
a date time, for
mm,
example, date times are uh, almost continuous. Of course,
mm,
everything is discrete in a computer, but yeah, they're effectively continuous. But yeah, you
makes
want
it more
periods to be
difficult.
discrete.
Um, then the as a task period as a predecessor, as a creator, and a GUID, because we can delete it and make another one.
Mm-hmm.
This condition is still working without change. The commented things were things that we had before,
Mm.
which I have not deleted yet, so I
Mm-hmm.
can look back. Yeah, I was still busy looking at that. Five
Yeah.
minutes. We have task delete, we have task restore, and then we have this is an entity reference, task
Mm-hmm.
task client, and there I have a first question for the naming of these things. You
Mm-hmm.
see, I added
Mm.
what is that called? The dash? Wait,
Yes.
here's a dash.
Yes.
Because we have entity reference and we have membership pattern.
Yeah.
And it's a little bit confusing if up to now we have always said
Mm.
WDS task.client as the
Right.
name for this type of link.
Mm-hmm.
But I'm wondering if we just put a dash in between the two predecessors, then it's
I
clear
see.
that this and
Yeah.
here I have singular and singular.
Mm-hmm.
That's an entity reference, yeah, because I start from a task and I
Hmm.
should only have one client.
Right. Right.
This is a membership pattern. I
Yeah.
task singular for task because that's where I start, and I can have multiple yards, so I put it in plural.
Oh, okay. Yeah.
It's
Yeah,
just an ID.
that is a difference,
Um,
and yeah, the naming convention wasn't capturing that difference, but
hmm,
yeah, that does make a lot of sense.
is that something useful or?
I think so.
Um,
I think so. Yeah. Bu- bu- bum. Yeah. Um. Um. Yeah. I'm still kind of feeling my way through the dash versus dot. But it does say something. There's a
hmm,
meaning
yeah.
behind that.
The
Yeah.
disadvantage is that in the name here you cannot put dashes,
That's true. Yeah.
but we didn't put dots neither.
No.
So,
No.
hmm. But
Yeah.
at least you see immediately from the name you see the pattern.
Mm-hmm. Yeah.
Um,
Yeah. I like that.
so if
Let me sit with that for a little bit,
uh,
and then I'll. Uh,
so
yeah.
for the moment, if you don't say no, I will try it until you say no, and then I haven't committed yet to GitHub.
Yeah. Well, this is
Mm,
ultimately this is your app. I know that we're building it as a public repository so that we can use it as a Janaga
mm.
example. But
No, but
yeah.
the the purpose is to establish best practices.
Mm-hmm.
Um, and I think that's something that you know better than me. Um, so I come up with small ideas, but if you say, Jan, that's because of things which I even haven't thought about,
Mm.
then it's better not to do it. Uh,
Yeah. Yeah. Nothing's popping to mind right
mm,
now that would make this a bad idea. So
mm.
um,
Let's see.
yeah.
Um, Here the same membership task tools. With the task tools delete.
Mm-hmm.
Yeah. And then we have task worker, which is an entity. You see, singular,
Mm-hmm.
so an entity
Got it.
reference. Um, but there, the activity was linked to an activity period.
Okay. Right. Right.
Yeah. So
Yeah, yeah. So using a separate period for activities. Okay, yeah, I like that
yeah.
because activities could continue on even an old task. Um,
Mhm.
yeah, so that makes sense.
And an activity has a worker as a predecessor.
Mm-hmm.
And the other one was what? Was for task, which had a
Yeah, the whole
supplier as
supplier. Yeah,
predecessor.
right, right. Yeah, because the task um, is really really a top level idea now. It's
Mm.
um, yeah, it's associated with a client and a yard, but not owned by them. So yeah, it needs to be up there at that point.
Mm.
Yeah.
So here again, entity reference, because the purpose is really to have a single worker assigned to a task, which we are not enforcing here,
Mm-hmm.
but we try to express it. This one was old stuff that I think we shouldn't use anymore, because now, before we copied the address of the yard
Mm.
into the task.
Right.
Let's see, because this one I haven't looked yet. I just I pressed the button just before connecting. So we have a Jinaga user, we have the tools, the yards, the workers, the clients, and the task. The
Mm-hmm.
task is the central thing.
Yeah.
And here
Yeah, I
we have
like
the
how that
membership.
worked out.
Yeah.
Mm-hmm.
So here we see the worker assigned,
Mm-hmm.
and we see the client assigned.
Yeah.
Um, if we want to know the address for a certain task, we go to the yard relationship. We go to the yard, and the yard has an address.
Yeah.
It's not mentioned here, but it has mutable properties.
Yeah. Yeah. So I think the problem that we were trying to solve in the past is that you might change the address of a yard. I can't remember exactly why, and you wanted that history of what was the address at the time that the task was created.
But is that's certainly useful? Perhaps for the client, I should use that. For example, the name of a client can change.
Yeah. Now, is it important to know what the name of the client was at the time the task was created? Or is the identity of the client really the only thing?
As long as we don't make invoices, no.
Yeah.
His telephone number, we don't need to know the old telephone number.
Yeah.
His email address, we don't need to know. An address of a yard normally doesn't change, and if it changed, we better know the new.
Yeah.
Unless the street has changed, but we better know the new name.
Yeah. So yeah, that sounds like you need to know the name at the time that the invoice is created. If we get to that point.
Yeah, but my software is normally not making invoices.
Yeah.
I always try to not to touch anything that has to do with money directly, because then you get into TVA, value-added tax rules, you get into currency issues, and accounting programs. There are so many of them which work good. So I prefer to connect to them, but not to do their work.
Yeah.
Because that's a complete different world.
Okay.
Yeah. Let me see.
Yeah,
questions.
looking at this diagram, that dash, that convention really does make a lot of sense. As you can see, all of those relationships right there at that same level, except for task delete, because that's not a relationship. That's actually a property of the an activity that happens on the task, and you can see that it's visually distinct from the others. So yeah, I'm liking that convention.
And there is a next item here, delete, which refers to that
that relationship,
that membership.
Yeah.
Okay, let's try it.
Yeah.
We can always. What were the questions I had? Proof the facts. Oh, yeah, that one we had. The period pattern we had. The naming we also discussed. Okay. Sometimes, especially for the main entities, you use a GUID to distinguish them. And for other things, like, for example, the mutable property pattern, you use a datetime. What is the...
Actually, for the mutable property pattern, we don't have any other distinguishing characteristic. It's all based on the value and prior, and of course the entity that's part of.
No, it's for the deletion, I think. Yeah.
Yeah.
Must be that. Create a date. Yeah. For the deletion of for example, a tool, they will use a date.
Yeah. Yeah. So my general pattern there is that I use a GUID for very top level things, and then date time once you've got other parts of the fact that will distinguish its identity.
And because these items can be created very rapidly when we import something, so that the
Oh,
resolution of datetime would not be enough. Is
that's
that the
right.
reason?
That we did. Yeah, that is something we ran into. Yeah, I forgot about that. Yes, yeah. So maybe maybe we do need to change those to goods as well. Yeah, because those are at some point going to be part of that import process, right?
Deletion, I don't think so.
Oh, okay.
Because most of the data of the databases, they don't store deletions. They don't store history.
Oh, right.
So,
Yeah. Yeah.
but if we import item, the creation of something, for example, we import customers. Well, we create, for example, 10,000 customers in a few seconds.
Yeah.
So there, the time resolution is not enough.
Yes.
We need
Yeah.
GUIDs. But
Yes. Very true.
deletions are never stored unless it is an historical database.
Yep.
Okay.
That's a good point.
Yeah. Work. Oh, that's good. Okay. Task client. How to make task client nullable? Here, this
Yeah.
one.
So you've got a nullable client reference there. Yeah.
Yeah, I put a question mark here,
Mm-hmm.
but he's complaining.
Okay. I think that's just because of Polyglot Notebooks. If you do that inside of your actual application, it'll be just fine. Yeah, that is the intended. Okay, yeah, and that's because the Polyglot Notebooks runtime does not enforce those nullability checks. It doesn't have nullable reference types enabled. So, so just client in the scope of the notebook would be considered nullable. But it wouldn't be considered nullable by Janaka, because when you interrogate the type system, Janaka would just see that the property of this record is a client. So that question mark, because Polyglot Notebooks doesn't enforce nullability, then that type would just be client. And I think if we scroll down and take a look at the diagram, we won't see a question mark on the diagram. No, no question mark there. Yeah, so that means the types that that it's giving to Janaka do not include nullability. But yeah, when you take that exact same code and put it into a runtime with nullable reference types enabled, then it will be interpreted. Excuse me. Will be interpreted differently by Janaka. Okay. That's a really interesting point. Yeah, I don't think that that we can even change that in Polyglot Notebooks. So yet another reason that we need Factual Studio.
The only pity thing is that we don't have the question mark here.
Right. Yeah.
But,
so the documentation is incorrect.
The little thing here doesn't really matter. I was just wondering why.
Yeah.
Yeah, that were all the questions. No more questions.
Okay.
But so you see, I only got there. Then I still have to transfer all that to .NET. Then I have to adapt the current code because I think the current code is not going to work with the new model.
Yeah, there will be some changes for sure.
But so that's going to be for next time.
Excellent. Yeah, I really like this this progress, and I really like the convention with the dash. Yeah, the extra consideration that you're putting into you know when do we need to copy data, when do we reference existing data. Um, yeah, this uh, this is historical modeling.
Mm.
This is what that's all about.
What I like a lot about the notebooks here
Mm-hmm.
is that we can just add the comments here.
Yeah, yeah,
Why we do things.
that is
Yeah.
really nice. Yeah,
Um,
I don't want to lose
all
that
the
in Factual Studio.
yeah, the thinking about it, because otherwise you start a model and afterwards you don't know anymore why we did it.
Yeah, yeah. Here's a thought. Uh, one popular standard is to use architectural decision records (ADRs) to capture decisions. So why we made this choice versus that? Um, so I'm wondering if Factual Studio could incorporate ADR support and um, and have you, use an ADR to document or to say what part of your model to document and then the reason to describe it, and then you'll end up with something like this. And so then just scrolling through your ADRs would be just like scrolling through this notebook.
Mm-hmm.
Yeah. Yeah, and then they would be individually source controlled, so you could see what was the history of this ADR, and it's just right there in source control.
Because that's a pity here. Um, if
Mm-hmm.
you yeah, I just committed, but if you ask Git here in VS Code to compare, it's a big mess.
Yeah.
What I did, I just copy and paste the code in WinMerge,
Mm-hmm.
and it's much better.
Oh, really?
I didn't dig deeper why. I just wanted to check something.
Hmm.
I didn't have the time to, but there I really saw the differences. Um,
Okay.
I don't.
Hmm.
I have to go and see why that was so much nicer.
Yeah, that would be interesting. Yeah, it might be possible to install WinMerge as your diff tool in Git,
Mm.
um, and then somehow tell Visual Studio Code to use it. There might be some instructions on how to do that. Yeah. Hmm. Or maybe they already have a Visual Studio Code extension that uses WinMerge within the window itself to just do the diffs,
Or
which would
perhaps
be
it
nice.
was already um, a differencing packet for notebooks.
Yeah, that's worth looking into. Because yeah, you're
Mm.
right. It is a bit of a mess.
Mm. But anyway, the moment that we
Yeah.
have Factual Studio, that would be
Yes.
then we don't need this anymore. But
Yes,
for the
indeed.
moment, it's the best we have. But the fact that you can really progress in the model and look at a small portion at a time,
Mm-hmm.
like tools and tasks, and have a limited diagram each time,
Mm-hmm.
that makes it really wonderful.
Yeah. Yeah.
Because
I
if
like
you
that.
have to see the whole diagram at once and work on it, um,
Yeah. Then it's a real
you really
mess.
have. Mm.
Yeah. Even if you turn it horizontal, like you have in one of your
Mm.
diagrams, it's like,
Yeah.
boom.
Yeah, but once we have everything in it, then I will make a new horizontal one.
Mm-hmm.
But when you're defining portions, it's better to have like this one. I think that's complicated enough.
Yeah.
Anything more will you lose the overview.
Yeah. Yeah. That is about the limit. And it really helps
Mm.
that this has that nice like willow tree
Mm.
structure to it. So the structure tells you the story. You see that DWS task is the central component here.
Yeah.
Yeah.
Yeah, because that tool tries not to overlap, so
Uh huh.
automatically the most important things are in the middle.
Yep. Very nice, very nice.
That's the
I like it.
progress.
That is progress. Excellent. Yeah, I made a little bit of progress as well.
Stop the sharing.
So I share screen 2, push the button. Yeah.
You looked into the injection containers?
Yes. Yes, indeed.
Yeah.
Yeah. So yeah, I brought in my old favorite Autofac. It's been a while since I've used Autofac, but yeah, this was kind of fun to bring it back in. I did this in 2 passes. The first time was using Claude and Rue code. Try to come up with a design. So okay, give me do a dependency analysis on this code, and how would you organize these modules? And it looked like it was going to go well, and then it said, okay, go, and it just boom made this huge mess. It's like, okay, let's check that in for posterity, but rewind, do this by hand, and much better result here. So the idea is you've got your container. So you build your container, register a bunch of dependencies, and then build. And now that you've got the container, you can resolve things out of it. And the only thing that we actually resolve here at the top level is the main window. And then call main window show, and then it starts the application up. Everything else that needs to come out of the container is injected into main window or something that it depends upon. So yeah, that's the only container.resolve that you ever see in the whole system. This on exit here, actually I don't need the exclamation point anymore. This on exit is going to dispose the container so that any iDisposable components that are registered within the container are disposed at that point. So it just goes through and cleans everything up. So nice and simple right here at the top level. So let's go down. Well, let's let's first explore down the path of the components themselves, and then we can talk about how they are registered. So the main window needs a command processor, a Janaga client, and this function, this task overview window factory. So a function that, given a supplier, will give you a task overview window. And that's the reason I want an Autofac right there, is that kind of thing. But the reason that we need a command processor is that when you click the Show Task Overview window, it's going to use the command processor in order to create sample data. Since that's doing a bunch of j.fact stuff, it's asynchronous, and so you need to run that asynchronously, and that's what command processor is for. Once we get past the sample data stage and we're actually persisting data and working with that persisted data, then that goes away, and we can actually just take this out of the constructor for main window, and we won't need that anymore. But then once you've got your supplier, then you call your create overview window factory function, pass in that supplier, and that gives you your task overview window. So I can be explicit, as you can see, yep, that's the actual type you're getting back. And then show dialog, and application starts. So simplified that quite a bit. Now, this function, the reason that Autofac is called Autofac is because it will automatically generate factory functions. So I have registered task overview window. I have not registered supplier. So supplier is a missing dependency. but it's able to construct that function to say, here are the missing dependencies, and then resolve everything else and go. So if I go to the console module, this is how we set up a whole bunch of dependencies for Autofac. We break them apart into modules. So I'll control open bracket S to select where we are in the Solution Explorer. So the console module is under DWS console. So I put these modules right at the top level because they're kind of the entry point. It might be better to tuck them away in a folder, but that's kind of been the pattern that I've used. And so this console module registers all of the things that are inside of the DWS console assembly. So we've got our Janaga config to create our Janaga client. The notification manager actually doesn't come from here. This comes from an npm package that we installed, but we still go ahead and register it in the container because some components need that notification manager. Then our command processor, our main window, and our task overview window. And I just noticed a problem. So right here, single instance, that's saying that anybody who asks for this notification manager or this Janaga config, this is actually the Janaga client that's registered here. Create Janaga client is the function that it should call in order to get that thing. But anybody who asks for one of these things is going to always get the same one. Versus when you ask for a main window or you ask for a task overview window, every time you ask, you get a different one. So with main window, you only ask this once, and so that one gets a main window. So there's really effectively no difference between instance per dependency and single instance in fact. However, I think single instance better documents the intent. So I'm going to change that. This one here, command processor, this is stateful. Isn't it? It's not. Actually, it's not stateful. Okay. Yeah, I was thinking that command processor had the queue of commands that were actively running and was managing those. At some point, it might need to do that. But yeah, actually, the way this is set up right now, it's just letting the task scheduler handle all those things. Nevertheless, the intent with the command processor is everybody's using the same command processor. So if in the future we do need to keep track of all the running commands, then we should just have one command processor that's got that list. So, and then with task overview window, since this is a child window of main window, there shouldn't be any prohibition against having multiples. So in fact, if I run this, then we're gonna try this out and see if you can create multiples. So here we are. So that's our main window. Then when we show task overview window, that creates the task overview window. And I don't think we've actually ever tried. Oh, we can't hit this button because this is a modal. Okay. If it weren't a modal, then we might actually be able to hit this button a second time and get another one.
Okay.
Yeah. But yeah, so in general, I want instance per dependency rather than single instance on Windows, except for the main window, which makes a lot of sense for that to be a single instance. So, the other interesting thing to talk about here, this as self, you are registering a class, so something that implements a service, as a type. So, so yeah, the idea in like in C#, a class is a class. A class is an implementation, but types can either be classes or interfaces, or the built-in types. But an interface is a type, or the class itself is a type. So a class is really two different things. It's both the implementation and it's the type. But when you resolve something from the container, like doing here, you're providing the type. So what's the thing that you want? And so when I register the main window as self, that means the main window type is what you'll use to resolve this from the container, versus say any interface that main window might implement. So if I did want to put interfaces on here and then have you be able to resolve based on those interfaces, then rather than as self, I could do as implemented interfaces. Or if I wanted to be even more specific about it, I could use as and specify the types, and I could chain those together as all of these types. Just these interfaces, no others. But for the most part, I'm using the class as type. And so you resolve that specific implementation. So yeah, this is one way to resolve things. Be explicit about it. Then another way is in direct dependencies. So here it's going to resolve command processor from the same container. So that's going to resolve that single instance and pass that into the main window. Or here resolving Janaga client, it is going to call this create Janaga client function just once because it's a single instance, and give you that Janaga client. If anybody else asks for a Janaga client, and just about everybody does, then they're going to get the same instance. So now this function here, task overview window, we're just resolving task overview window as self, and its constructor takes a task overview view model, command processor, Janaga client, and there we go, the supplier. So it's asking for a lot of things, but it's only the supplier that we need to provide at runtime. And we provide that at runtime because we just called, oops, it wasn't here, it was in the main window, yeah. We just called create sample data, and that's how we got our supplier. So that's a kind of a runtime idea. So we get our supplier at runtime, and so the supplier is not going to be in the container, but the rest of these things are. And so Autofac is able to basically compress this down to where it just calls one. It gives you one function where you have this one parameter, and then it figures out the others from the container and builds that for you. So that's really nice. I like that. So here, actually, yeah, I have not continued the pattern. Well, let's continue the pattern since we're here. And yeah, we have just a few minutes. So rather than creating a new task view model right here, well, new task view model and a new task dialog, I want to use the same pattern. So ultimately what I'm trying to do is new task dialog, show dialog. So what I really want is a function that, so let me, in fact, I'll go to a new line to make it a little easier to read. So I want a function that takes a supplier and gives me back a new task dialog for that supplier. That way I can use it here. Yeah, right. So I specifically want this to be a factory function so that I can pop up a new dialog. The dialog doesn't exist before I actually click this button, and I get a new one every time. So yeah, I'll want to register a new task dialog as a well, in other containers it's called transient. In this one, instance per dependency. So so this is a new task dialog factory. And this will allow us to follow the tried and true policy of no news is good news. So we should be able to get new out of our code. So now we don't need the view model. All we need is the new task dialog factory, and we're going to pass it the supplier. And so that will create our new task dialog, and we'll be able to show it. So, yeah, interesting. Now that I've done that, I no longer have this dependency on Janaka client because I'm not passing it in. So all these transient dependencies can start to go away. So, so yeah, let's get rid of Janaka client here. And I just get rid of it there. And so we should be one step closer. Now, what's also interesting is I only need this supplier as a parameter to this function. We might not even need to pass the supplier in. I'll do this one step at a time, so I'll keep that around. But yeah, that might be the case. But another thing here, there's no async happening inside of this. So why don't we do this and get rid of the need for the command processor? So that's starting to look even simpler. Yeah, so this task overview view model, yep, I need to load and unload that, so definitely need that one. That's the view model for this window. And I also set that as the data context. Yeah, okay, so we might actually be able to get rid of this one, but let's take this one step at a time. Now here I think we are going to run into a problem. So let me just Control F5 to run it and see if this works. So show task overview window this is where it probably will break. Boom, and well, oh, maybe it showed up on the, there it is. Yeah. Well, for some reason it's not showing up in the right place on my two monitor setup. It's just right through the middle of the monitors. But yeah, there's an exception that's happening here. So let's run and debug, see if we can capture that. Yeah, it's a caught exception, so I think I need to get even more specific about how I manage exceptions. So Control Q, exception settings. There we go. And I'll just check that box. All common language runtime exceptions, even if they're handled. Now let's see. There we go. Okay. So none of the constructors found on type task overview window can be invoked with the available services and parameters. And then we go down one more level. Can't resolve func of supplier task new task view model. Yeah, ultimately we get down to the very bottom of the exception and it tells us what really happened. So it's this func of supplier to new task dialog. It cannot resolve that one. And so yeah, this is something that I rediscovered while I was working on this. I was like, oh yeah, I forgot that Autofac has this limitation. It will automatically generate a factory function for just one level. So we go here and we try to resolve the main window, and yeah, main window has this one function. So task overview window takes a supplier. But now in task overview window, so we still have the supplier parameter, but this task overview view model also, oops, wrong one. Let me go to this one. There we go. This also takes a supplier. So the intent is you give it that parameter once, and then it figures out all of the dependencies that need it and fills them in. Unfortunately, Autofac does not just do those transitive dependencies by default. And so I did a bit of digging around, and I found this. So here's a link on Stack Overflow where this is all talked about and discussed. Yeah, this is kind of a common problem. In Autofac delegate factories, that's what this feature is called, where it creates a func. It's a delegate factory. Can it pass parameters to nested objects? And the answer is no, but you can make it do that. This is the old way of doing that. Things have changed. This is the new way of doing that. So I don't know if I upvoted it. Oh, that's right. I'm on the wrong. Anyway, so basically took that. I expanded it out to give it nice error messages, and so with this, we're able to kind of fix that problem. So I gave it this nice little extension method. So now as you're registering a type, like this task overview view model, the second level down, you say this should create a transitive factory. So if somebody needs to automatically create a factory one level up, then it'll work with this. So all that to say, the problem that we're having right now is that we just added this new task window. So here's the console module. So that means I need a builder register type for the new task dialog. And that's going to be instance per dependency. And because it needs, because it needs the, actually it's not this one that you put that decorator on, because this is the actual function that we're calling. But its dependency, right here, the new task view model, that's where you put the decorator. So if we go to the console module, well, wait a minute. No, I want the view model. Yeah, here's the view model. That is in the view models, and so we use the console view models module, And so in here, we can register type the new task view model. Make sure that we, bring that in. And then that's going to be as self, instance per dependency, and transitive factory. So with all those, we should be able to accomplish this. Let's see. Yep, and now it starts it up. And so when I push this button, it actually calls the generated factory function to create the view model, create the dialog, and inject everything else. So now we have that behavior. So that is the advantage of dependency injection, the advantage of Autofac, but also a shortcoming of Autofac and how to overcome that shortcoming. Yeah, so what do you think? See, I'm not hearing anything. Are you on mute right now?
Do you hear me now?
Yes. Yeah, there you are.
Oh, because the red light was flashing, but I didn't see any sign that I was on mute.
Huh.
Strange. No, I think it's nice to have it now. Before we add additional things to the software.
Yeah.
And it's gonna make life easier once we are used to work with it.
Yes. Yeah, it does take a little bit of getting used to, but
that's with everything that is progress.
Yeah.
You need to learn the tools before they can help.
Yep, that is true. Okay, so I'll push that change up there. So yeah, there's already a pull request open that has those changes.
Because that's still on the Autofac branch.
Yes. Okay. Yep. So I will let you get your stuff merged in before we try to merge this PR, just in case there are any merge conflicts.
Because I'm still on that on one of the other branches.
Yeah, actually, I opened this PR against the branch that you're working on, rather than go all the way back to main. Yeah, so that should be fine.
All right.
Yeah, pull requests. Yeah, here's the extreme Autofac. you can look at that one to see. Oh my goodness, it made a big mess. But yeah, here's the.
That's the one that was automatically implemented.
Yeah. Yeah. That's what happens when you give Claude a little bit too much freedom. Like, all right, come on back. All right. There we go. We got that stuff. So that is yeah. So yeah, we'll get your stuff merged in. We can merge that PR. Yeah, there might still be some more things that I can clean up in there. Get rid of any other places where we're where we have new, and so get rid of all the news. And then in that one case, there might even be able to get rid of that supplier, because it should be able to just create that factory, given that it was already given a supplier from the top. That might be asking a little bit too much, but we'll see. We'll see if that works.
Okay, I will finish that model, then merge in, and then we can merge everything in the main.
Very good.
Yeah, because that branch I'm working on, it can continue, but I can better finalize it and then start another one.
Yeah, I like that plan.
Okay, I continue on the model and then adapt the software to the new model. Then I still have to implement that edit button. Then we should have a complete screen working.
Yeah, that's exciting progress. Very good. Still a long way to go, but getting there steadily.
We will get there.
Yeah.
Okay. Next Thursday, you will be there?
Yes, I will.
Okay, I will be there as well.
Very good.
Michael, thank you very much, and see you next Thursday.
Thanks, John. See you then.
Okay, bye-bye.
Bye.